Alright, today we're going to do a quick solving review before we take our test. So we're going to go through first power functions. So these are power functions again because x is our base, right? So we're just going to solve these just like we normally would, using the order of operations backwards. So we need to first get rid of our addition and subtraction. So this we're going to add 4. We get x to the 3/2 equals 20. And then we're going to raise it to the opposite exponent, which is to the 2/3. And so x is going to equal 20 to the 2/3. And I do not have a calculator on me tonight, so you would type that in your calculator. 20, caret key, parentheses, 2/3, and get your answer. This other one is also a power function. I liked the number 4 because x is our base. So we're going to undo it by subtracting 4. And I get the 4th root of x to the 3rd equals 8. And I'm going to rewrite this as, I'm going to rewrite this as x to the 3/4 equals 8. And again, I'm going to raise it to the opposite exponent, which is 4/3. And whatever I do to this side, I have to do this side. So I get 8 to the 4/3, and again, I don't have a calculator, so you would type that in as 8, caret key, 4 divided 3, and get in your decimal, and round to 2 decimals. Right. More importantly, we're going to review exponential functions because I think most people have those ones down. So an exponential function, you should think I need a common base. So when I look at this first example, I see 27 and 9, so I should think a base of 3. So 27 is the same as 3 to the 3rd, and that's still raised to the x. And 9 is 3 to the 2nd. Power to a power, I multiply these two. So my next step is 3 to the 3x equals 3 squared. When I have a common base, I basically just solve for the exponents. So 3x equals 2. So in the end, x should equal 2/3. Again, if you have a calculator, you can type that back in for your exponent and see what it gives you. This one we don't need a calculator for if we wanted to check it. We do 27 to the 2/3. Again, that's the same thing as 27 to the 1/3 squared. The cube root of 27 is 3. Squaring that gives us 9, so we got the correct answer. Right, we're going to move on to the next one now, which is a little bit more complicated, but the nice thing is it's already got a common base. So all the bases are 7. So what we're going to do is we see this divide. When I divide, you should think subtract. So you're going to get 7 to the 5 minus x equals 7 to the 3x minus 1. Okay, when I have the same base, I'm done. So now I just set my exponents equal. 5x equals 3x minus 1. Solve it, so I'm going to add x to this side. I get 4x. I'm going to add 1. So I get 4x equals 6. Divide by 4. I get x equals 6/4, which is equivalent to 3/2. Right? Now we're going to move on to the next one, which again, going too far. No, scroll back up. Alright, so now we have stop. Now we have a base of 6, and so we just have to make this 36 into a base of 6. So I have 6 to the x equals 6 to 2x times 36 is 6 squared. When I multiply two bases, I add the exponent, so I get 6 to the x equals 6 to the 2x plus 2. I have a common base now. I cross them out. Get x equals 2x plus 2. Subtract 2x from both sides. Negative x equals 2. Negative x equals 2, then x equals negative 2. Right? Got 3 more examples to show you. This one, you look and you see I have 25, 5, 125, and 5. you should be thinking a base of 5. So on top we have 5 squared, still raised to the m. On the bottom we have 5 squared. 125 is the same as 5 to the third times 5 to the m. So this one involves two properties. Okay, first one, multiply those, so I get 5 to the 2m over 5 squared equals 5 to the third times 5 to the m. When I divide, I subtract, so I get 5 to the 2m minus 2. And when I multiply, I add, so I get 5 to the 3 plus m. Once I get the same base, I can just solve for the exponents. So I'm going to get 2m minus 2 equals 3 plus m. I'm going to minus m from this side and get 1m. I'm going to add 2, add 2. I get 1m equals 5, and that's my final answer. Right, 2 more to go. Right, so this one is 5 times 3 to the x equals 135. So what I'm going to do, excuse my writing here. So the first thing is I'm going to get rid of that 5 by dividing because it's not in the same base. So I'm going to get rid of that. So I get 3 to the x equals 135 divided by 5 is what? Sorry, I don't have a calculator like I said. It's 2. $27. So I get 3x equals 27. Now that's the nice number. So I get 3 to the x equals 3 to the third. So I get x equals 3. Right, and the last one we're going to do is obvious that it's a base of 5. So I get 5 times 5 squared, still raised to the 2x because 25 is 5 squared, equals 5 to the negative 9. Again, when I multiply, I add my exponents. So I get 5 to the first times 5 to the 4x equals 5 to the negative 9 because I need to multiply these two. So I get 5 to the 1 plus 4x, which equals 5 to the negative 9. Now I have the same base, so I can solve. So I get 1 plus 4x equals negative 9, minus 1, minus 1. 4x equals negative 10. X equals negative 10 fourths, which is the same thing as negative 5 halves. Right? I hope that helps with your solving. Good luck on your test today. Do your best. Please note that for number 15, you're going to have to write your answer in because the correct answer isn't listed. And have a good holiday. I will see you when we return.